BSc Chemistry Terpenes presented by Dr. Giridhar M. Assistant Professor of Chemistry Department of Collegiate Education. Contents: classification of terpenes and terpenoids, isolation of mono and sesquiterpenoids, steam distillation method for extractions of terpenes, and then solvent extraction method.
We will move to classification of terpenoid. So most natural terpenoid hydrocarbons have the general formula C5H8N. They can be classified on the basis of value of N, that or the number of carbon atoms present in the structure. So here we can see whenever value of N is 2, it is called as monoterpenoid. That means 2 isoprene units are there in this and total 10 carbon atom. When value of N is 3, that is when it contains 3 isoprene units, it is called as sesquiterpenoid, and the number of carbon atoms present is 15. And whenever 4 isoprene units are present, so it has 20 carbon and it is called diterpenoids. When 5 isoprene units are present, 25 carbon atoms will be present and it is called sesquiterpenoid. When 6 carbon atoms are present, a total of 30 carbon atoms will be present and it is called troterpenoid. And when 8 isoprene units are there, 40 carbons are possible in that molecule and it is called tetraterpenoid. And when 9, okay, so this is 9, when 9 isoprene units will be there, so 45 carbons will be there and it is called as polyterpenoids. And further, each of these can be subdivided into subclasses according to number of ring present in the structure. So that means monoterpenoid can be further classified as acyclic terpenoid. Acyclic terpenoid does not contain any, it contains only open structure, it does not contain any ring. Monocyclic terpenoid, it contains only one ring in the structure. Bicyclic terpenoid, it contains 2 rings in the structure. Tricyclic terpenoid, it contains 3 rings in the structure. Tetracyclic terpenoid, it contains 4 rings in the structure. So example for monoterpenoid. So as I already told, monoterpenoid can be further classified as acyclic monoterpenoid. So example for this is myrcene, citrol, gerinol. Okay, 2 isoprene units will be there. That is in monoterpenoids 2 isoprene units, and this is acyclic monoterpenoid. So there will be no cyclic ring structure. And next one is monocyclic monoterpenoid. Mono means 1 ring will be there here. So 2 isoprene unit with 1 ring. So example is limonene, alpha terpenol, menthol. So limonene is the one compound which is found in the lemon peel. ಅಂದ್ರೆ ಕಿತ್ಲೆ ಹಣ್ಣಿನ ಸಿಪ್ಪೆಯಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ರಸ ಏನಿದೆಯಲ್ಲ, that is limonene. Okay, limonene. Similarly, third one is bicyclic monoterpenoid. Bicyclic ಅಂದ್ರೆ here it contains 2 rings, and monoterpenoid means 2 isoprene units. So this is thujane, which is 6 plus 3 membered ring, pinene 6 plus 4 membered ring, camphor 6 plus 5 membered ring. Second one is sesquiterpenoid. So as I already told, here N value is 3. That means 3 isoprene units will be there. And for examples, further this can be classified as acyclic sesquiterpenoid. This is not monoterpenoid, acyclic sesquiterpenoid. So farnesol, Zinzenberg Berne is monocyclic monoterpenoid, and 3 cadinine is bicyclic sesquiterpenoid.
Isolation of mono and sesquiterpenoids. Both mono and sesquiterpenoids have common source, that is essential oil. their isolation is carried out in two steps. So one is isolation can be carried out from essential oils from plant parts, okay, and second one is separation of terpenoids from essential oils. So these are the two methods. One is from plant parts and one is directly from essential oils. So there are four methods of extraction of oils. One is expression method, steam distillation, extraction by means of volatile solvents, adsorption in purified fat. In this we have to study steam distillation and extraction by means of volatile solvent. So let us move to steam distillation. So steam distillation is most widely used method. In this method macerated plant. So ಇಲ್ಲಿ macerated ಅಂದರೆ the plant material is brought, it is grinded into fine powder, or in water it is grinded in water to give macerated plant material, which is steam distilled, okay, with water when steam distilled. So now what happens, whatever will evaporate, along with this our terpenes will also evaporate and it passes through this condenser and finally it condenses and drops here, collects here as liquid. And these terpenoids, they are oils, they are not miscible with water and hence they can be separated by using solvent extraction funnel. Okay, by using solvent extraction funnel we can separate both this oil and liquid. If our terpenoid which we have to extract will undergo decomposition at high temperature, then here it is extracted with, initially the plant material is filtered, the clear liquid is extracted with petrol at 50 degrees centigrade to obtain terpenoids. Okay, after evaporation of petrol we get terpenoid. So this is steam distillation method. So plant material is macerated and then filtered to remove plant material and then it is distilled to get terpene as well as water, which can be separated by using solvent extraction funnel. Extraction by means of volatile solvent. Solvent extraction is done by submerging plant material in solvent. So usually the solvents used are methanol, hexane, ethanol. So here plant material is submerged in solvents like methanol, ethanol, hexane. So and the terpenes are extracted into the solvent after soaking for some time, maybe 1 day or 2 days. Then plant material is removed and solvent is evaporated, leaving behind terpenes. So this is by using volatile solvents. So different solvents can be used and selection of solvent depends upon the type of terpene we have to extract. For example, the method which we use for gamma terpene cannot be used for para-cymene. So for each terpene to be extracted, different method has to be developed. So these are the references. Thank you.